We have a many scheduling algorithms. Among them, the simplest one is the first come first serve. We have a lot of processes in a ready queue, and there is only one CPU. And we are going to pick one of the process from the ready queue, and we are going to allocate the CPU for that. And what is the criteria that you will be looking at? The first come first serve, the name itself says that the whichever the process comes first into the system, that will be given the first preference. So here we are going to consider the arrival time of each process, and the mode we are going to say take it as a non-preemptive. Non-preemptive means that once we choose the process from a ready queue and once we allocate a CPU for that, and it will uh, not be removed from the CPU until it finishes its work. So this in this diagram it is shown that the this is the first in first out ready queue, and whichever the process which enters first, that will get the CPU first. So it is a non-preemptive. Non-preemptive means with the once it gets the CPU, it will not be preempted from the system. Now I will explain this with a one example, and here we are going in this we are going to consider all the processes are CPU time bound processes, not IO bound. So there is a no blocking states. So once the process is created and it enters into the new state, and once new state, once it gets ready and it enters into the ready state, and from the ready state the CPU will be allocated based upon their arrival time. And once it gets executed, it enters into the termination state. So in this example we have taken 5 processes, and they 5 processes, they are represented by the process number P1, that is 1 2 3 4. And in this we have their arrival timing also, and the process execution or the burst timing also. So this indicates that process P1 which has arrived at a time 0, and which requires the for execution it requires a 4 time slot. Similarly, P2 which has arrived at P1, and that is a time slot, it is a 1, and which requires the burst time, it is a 3. Similarly, the P3 which has arrived at 2, which requires the execution time, it is a 1 unit. And P4 which has arrived at 3, and which requires 2 time slot. And the process 5 which arrived at a 5 and which requires the burst time, it is a 5. Now we will consider the Gantt chart representation. So this Gantt chart representation, it specifies that the processes which are entering into the system and when they get completed. So the process P1 which has entered into the system, it is a 0, and which requires the 4 time slot, and which has completed it a 4 time slot 4. And the P2 which has arrived at a 1 only. By the time slot 4, all the processes that like P2, P3 and a P4 and a P5 in this example, all are will be in the ready queue. Which one we are going to choose means this is the first come first serve algorithm. So here we are going to consider the arrival time of the each process. So which process has come first? The P2, that is a process 2 which has entered earlier than all the processes. So now we are going to choose a process P2. So the after finishing P1, the P2 will take, and the P2, the execution time required for the P2, it is a 3 time slot. So from 4 it will start and it will complete by the time slot, it is a 7. Now we are going to choose a P3 because which has arrived at a time slot, it is a 2, and which requires the execution time, it is a 1. So the P3 which will start executing at a time slot 7 and it will get over by the time slot, it is a 8. Similarly, P4 it will start executing at a 8 and which requires the burst time, it is a 2, and it will get over by a 10. Similarly, the process P5 which start executing at 11, and the burst time which is required, it is a 5, and it will get over by the 15. This in this we have shown the completion time. The completion time is nothing but it is the at what time the process get completed. So in this, the process P1, that is a 1, which has completed at a 4, and the process P2 which has completed at a 7, process P3 which has completed at a 8, process 4 which has completed at a 10, and the process 5 which has completed at a 15. Similarly, we can calculate the turnaround time. The turnaround time is nothing but a total amount of time, which is the total amount of time spent by the process in the system. This is nothing but a completion time minus arrival time, which will give the turnaround time. So we'll see this here. See, the turnaround time of the process 1 is completion time is 4 CT minus AT. So 4 minus 0 is 4. 4 is the turnaround time of the process 1. Similarly, for a process 2, 7 is the completion time, and mine arrival time is 1. So it is the turnaround time is the 6. Similarly, the process P3, 8 minus 2 is 6. Similarly, for a process 4, it is a 10 minus 3, it is a 7. Similarly, for a 5, it is a 15 minus 4 is nothing but it is a 11. So this is a turnaround time. Turnaround time is nothing but it is a total amount of time which is spent by the process in the system. And now we'll consider the waiting time. Waiting time means it is the amount of time a process has been waiting in a ready queue. So this is nothing but a waiting time is nothing but a turnaround time minus the burst time, which will give the waiting time. So here we have it is a turnaround time. Turnaround time is 4. The burst time is 4. So 4 minus 4, which will give the waiting time, is 0 for the process 1. For a process 2, it is a 6. Turnaround time is 6. And the burst time is 3. So which will give 6 minus 3, it will give it is a 3. Similarly, for the process 3, it is a turnaround time, it is a 6. 6 minus the burst time, it is a 1. So which will give it is a 5. Similarly, for a process 4, it is a 7 minus 2 is a 5. For process 5, it is 11 minus 5 is 6. This is the waiting time. In order to calculate the average waiting time or a average waiting time, we need to add up the all the average time of the waiting time of each process divided by the total number of process which are existing in the system. And similarly, we can find the total amount, total turnaround, that is the average total turnaround time, that is nothing but a turnaround time of each process divided by the total number of processes, which will give the average total turnaround time.